Thanks for coming, everybody. My name is Justin Grote. Today I'm going to be showing you a high-performance way of installing PowerShell modules that I developed. I'm a data center solutions architect with Allied Digital. I'm also a Microsoft MVP, and I'm looking forward to showing you this kind of fun little thing that I built. Many thanks, of course, to all of the sponsors that make PSConfEU happen and allow all of us to come together: Chocolatey, Centino, Patch My PC, and ScriptRunner. Also, big thanks to Allied Digital for sponsoring my travel here. My company is a worldwide managed services provider. We basically take over IT departments, and we're able to, when you treat certain things like, you don't get your own electricity you don't generate your own electricity, you don't do your own plumbing. We handle a lot of the infrastructure and day-to-day stuff so that you can focus on your business's core competency. So if that's something maybe your company's looking for, give Allied Digital a call. So why did I make this thing at all? The thing about came along is that there was simply an aspect of when building modules and installing modules, PowerShell Git version 2 as it currently exists is pretty slow, especially if you're trying to do things like you need to install a lot of modules. And that doesn't really matter when it's just your computer. If you just are installing a few modules and you got them and you're good. But when you're working in environments like continuous deployment scenarios or anywhere where you need to iterate over and over again Azure functions, then suddenly that process of pulling from the gallery and such using the current options starts getting very, very slow. I mean, even just doing something as pulling a large amount of Azure modules can take a minute or two. And if that's in an Azure function, that's all part of your cold start. And that's just that much longer till your application's available for people to use. So there's been some discussions about how to improve it. A few different ways, and then PowerShell Git version 3 has been in development for a very long time, gone through a few iterations, but also still just due to the nature of it just isn't really still meant for that kind of scenario. So I got to the point where I needed something that was going to meet this use case. So I made something. So what ModuleFast is that it's primarily optimized for these type of scenarios. It's meant for areas where you have a fresh PowerShell session in a container, in a action, in Azure functions, anywhere where you're starting a PowerShell and you want to fetch those extra dependencies really, really fast. Another thing that I wanted with it is I wanted to be more declarative about what you want. If you want to be able to specify the modules and the versions, and basically you want to specify what your end state wants to look like. You don't want to specify what to install and then suddenly find out there are conflicts. Instead, have you specify what's your end state you want to have look like, and then have the module go ahead and go through and figure all the stuff out for where you need to go. If you ever use Terraform or Bicep or any of these kind of things, you're sort of familiar with this concept in the infrastructure as code arena. This really just brings it into a much smaller, much more, a smaller environment, but the concepts are still the same. The other aspect is very important is to be able to also be able to preview what's going to happen before it actually happens. So the architecture of the application has the same sort of plan, apply, declarative style as you have with Terraform. You can get a plan of what is going to be installed before you ever actually install. And that's very helpful for getting an idea of how things are going to be laid out before they start. And because it was fun. It was a project that I used to learn a few things. I learned a lot about certain PowerShell internals, and I learned a lot about how the packaging currently works. And I always say that one of the best ways to learn PowerShell, or really any kind of language, is have something that you want to do and then just start trying to accomplish it. And you will learn so much and get a lot of expertise in that just by going through that process. And it was a lot of fun, like finding these things. So I've actually been working on something like this for several years, and this wasn't something that I just I'll just whack, 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 done, worked. I tried a lot of different ways and had lots of false starts and had lots of frustrating times where I was just like, to heck with it, I'm just going to continue to use PowerShell Git for now. And hopefully then PowerShell Git version 3 came along, and I was like, oh, this might do it. And then it didn't quite do what I needed. But eventually I did actually finally get to a place. But trying to get there, first thing I did, as I always say, as you see in my other talks, is like, don't reinvent the wheel. If somebody's already gone to all the trouble to install something, test it. If there's a community behind it, if something already exists, if you can leverage that, you should, because why would you reinvent the wheel unless you have a very specific reason not to? So all of the stuff that powers PowerShell Git version 2 under the hood is provided by Microsoft. The protocol that's used to go and fetch packages and resolve that is known as NuGet, as well as NuGet packages. And so just trying to use those first-party Microsoft DLLs that they use to do that was sort of like the first approach to try to get this to work. Unfortunately, those DLLs, a lot of them, especially in terms of the V2 versions, are undocumented. The approaches and the programming styles you have to work with them are very, at least cumbersome for me, especially coming from primarily like a PowerShell background. Like I'm getting okay at C#, but I'm not really like, I don't really know patterns. I don't have a computer science degree, so I'm not really in the mindset that maybe somebody else picking up would be able to work with it. It was very difficult to work with, lots of bugs, obtuse error messages, and basically zero support. Like there was no way to get any information on it. So there's another engine that's used for packaging with what's primarily with the F# language, but it works just fine with C#. It's a .NET packaging system known as Packet. And so Packet was basically the same, trying to accomplish a lot of the same things I wanted to accomplish. They ran into the same issues other people had with these kind of packaging and dealing with these assemblies and such in the .NET world. But PowerShell modules, when they're hosted on the gallery, use basically the same infrastructure that C# like modules and packages do. So they made a new engine that had a much better dependency handling algorithm, could be declarative, works with a requirements file, and was engineered for those kind of like C#, F# projects. But again, they had solved a lot of those problems. And so I was like, oh, can I reinvent and use this? And I was reasonably successful with making something that was fairly able to tie into this, as well as using .NET Restore, which is also very fast and very effective. But the problems that ended up with that being is that I had a dependency to need the entire .NET SDK installed. So at the time that I was working on this, it wasn't as ubiquitous as it was now. So if I was doing something in GitHub Actions, for instance, and you wanted to use this way, your dependencies were to have to download like the entire 120, 200 megabyte .NET framework, because there was no way to extract just that package management piece out. So you ended up just being slower than just using PowerShell Git version 2 in the first place. Like if you were working somewhere where you already had it installed, it was plenty fast, but you still had this big looming dependency that had to come along. And so clearly at that point, I was like, okay, well, I probably need to have something that has fewer dependencies. It's like slimmer, lighter, focused just on this. But again, I was very unsure about that. I wanted to write things in PowerShell, and I was really shying away from actually building a new data model and a way to represent these things as they need to. I thought if I can get away with what other people are writing, and because they're smarter than me, that's what I should do. Because then, especially if there's bugs or there's issues, hopefully those get fixed outside of me without having to be super dependent on it. But as I built a little more confidence, built a little more knowledge around like starting mostly with TypeScript and then how those concepts translated to C#, I started to realize that there's ways to do that. And as I learned more about the relationships of PowerShell to C# and how .NET PowerShell classes work, under the hood and those kind of things, I built up enough confidence to say I can probably do this all actually 100% in PowerShell without having to have any kind of dependencies or even write it in C#. Because the problem with writing it in C# would be that if I want to install, I want this to work pretty much anywhere. I want you to be able to just bootstrap it and have it work as fast as possible. And if I do it in C#, then that means I have to have DLLs, and that usually means like virus scanning programs are going to look at those and maybe intercept, drop, whereas if it's in a PowerShell script, it may be an unsigned PowerShell script, although I also provide a signed version, but you have to have those that it's just in my experience, it was just much more likely to just work in a lot of environments, because especially in the environments where you're trying to do these things, they've been pre-set up to work for scripts. Because when you're doing GitHub Actions or Azure pipelines or Azure functions, you're doing things where scripts have to run. So they've already sorted out a lot of that kind of security type stuff. So these things tend to just work there. So that's when we ended up with, I think this slide's out of order, one second. No, okay, so just going back to, again, why ModuleFast. So that's why I built ModuleFast, is that what ModuleFast provides is it's just a PowerShell script. It's a very long PowerShell script, which you'll see in a bit when we get to the section about it. But it is basically takes a lot of the things where I went through the performance of how PowerShell Git version 2 works and found ways to fix those or improve those. If you were in Jakob's session earlier about using like a profiler and such to improve your code, I effectively did like a version of that where I looked, okay, here's where the slow parts are. Here's places where things are just sitting there doing nothing. Maybe for good reason, maybe not for good reason. And the whole goal was to build something that was going to be super performant and be able to do that. So if I come out here to the ModuleFast repository, I have sort of a description about that. I also was very proud of this logo, which I made, and I also discovered something that I showed as well, is that just through dumb luck experimentation, when I published the actual module, I found I could make it on the gallery do the same thing. So I'm pretty sure I have the only module with an animated logo on it in the gallery. So, but yeah, I like that. I really like that. It perfectly represents what ModuleFast is. Is that it is a quick and dirty, super fast. Little error checking, little things. But the whole point is to just go as fast as possible to deploy a module, to get those modules deployed. If we're talking a production environment where we're trying to roll out to servers, we want lots of checks, lots of safety checks, lots of doubling up, verifying those things. And that's like the key focus. And that's primarily why PowerShell Git and PowerShell Git version 3 have both taken so long and still have some performance aspects, is because they need to remain compatible. The focus with those is that if you do install module today, install PS resource should work. And if you're doing it on a 10-year-old server, it should still work. Like, again, that broad level of compatibility that has to exist requires handling all these edge cases and all that kind of stuff. However, my use case is that I just need to put it into environments that just get thrown away in 10 seconds anyways. So it's less about the long-term life cycle of those modules and just getting those modules down onto that system as fast as possible. So that's the focus of ModuleFast. It's very good at doing that sort of thing. It does work just fine for managing your local modules, but if you're trying to do a lot of complex use cases or trying to integrate this with Ansible, it's probably not best for those. It certainly could be if it's upgraded and had like a lot of those edge cases handled and worked out. But again, I have limited time, limited resources. My focus is making this on just being a very fast way to deploy modules very quickly and in a nice way. So one of the aspects about making that very fast is that ModuleFast doesn't even require you to install it, because to install ModuleFast as a module, you're still dependent on PowerShell Git to install and the slowness that occurs in PowerShell Git to then get to the point to install. So you can actually just simply run this command, which is a short little version that basically says, go to this link, which is basically just points to the repository. It's just a short link that goes, oops, let me, bit.ly/modulefast. You go there and this, well, it did the opening it directly. Let me point to where it goes. GitHub.com, just Grote ModuleFast. So that basically that link, when you take it, what it downloaded was this file, which is basically just a bootstrap that will find the latest GitHub release of the script, pull it down, and bring it available and make it available in an ephemeral way. And then once everything's complete, it'll go ahead and remove it and clean it out. Otherwise, it'll stay in memory. So as a demo of that, if I take this guy here, and I put it in my terminal, just like that, it goes out, fetches it, downloads it, and brings it back. And now I have my ModuleFast commands with my full caps lock. So there's ModuleFast. It's got the commands. AirKit command. So it comes with just two simple commands. One is for the actual installation of the modules, and the other is for getting an object version of the declarative plan. So if you're familiar with Terraform and other things like that, the top one is Terraform apply, the bottom one is Terraform, top one is Terraform plan, the bottom one is Terraform apply. And so the way that this works is that the main areas that I found that were sort of the slowness aspects are, one aspect is in ModuleFast, when the PowerShell Git version 2 and version 3 fetch information about modules, it does them one at a time in a synchronous serial way. So say you're installing the Azure module. If you've ever just done install module AZ, you know it takes it can take anywhere between 3 minutes to 15 minutes depending on your computer and the speed of your internet connection. And the reason why that is that if you actually run like Fiddler and you watch what it's doing, it's going out to the gallery and it first starts, give me information about AZ, like the AZ meta module. So it grabs that, gets the information, sees, okay, there's all these other modules that are dependencies. Let me get the information about those so that I can build what I need to install. So then it goes out and grabs, AZ application insights, grabs that, comes back, reads it. Then it goes out and gets AZ, compute, grabs that, comes back, reads it. That round trip time every time to the PowerShell gallery it just becomes this multiplicative effect of it just takes longer and longer and longer. That's also not helped by the fact that the PowerShell gallery is built on still currently on a relatively old design. It's basically like a glorified SQL server with a Azure CDN keeping the packages. Any query to the PowerShell gallery, regardless of how you structure it, pretty much takes between 400 and 500 milliseconds to come back. Even if you're like right next to, if I'm in Azure and I'm right next to where that thing is running, where my ping time to the thing is like 3 milliseconds, that query time is still 400 to 500 milliseconds. So you multiply that by 80 in the number of dependent modules you're trying to pick up, and you can see how that really multiplies to the point that that's why it takes 15 minutes. It's 80 modules times half a second each of them is at least 40 seconds just to get the information. And then when it comes time to install those modules, it goes out, grabs the package, waits for that one package to download, and then installs it, and then goes out, waits for the next package, downloads, waits to install it. We can kind of see that if we do like an install module az-verbose. Actually, sometimes the verbose doesn't capture everything the way it's written, so I'm just going to do a verbose preference continue here. And so you'll see it's searching that. I do want to install. And so you'll see here, there's going find package by ID. See each step, get that, get that, get that, get that. You notice each time it's about maybe half a second, 300 milliseconds if we're lucky because of caching and such. Here, we haven't even started installing any modules yet. We're just going one at a time, one at a time, one at a time. So that's one of the first things that's fixed in ModuleFast. So the way the ModuleFast operates is, I don't have my, do I have my repository? I do have my repository. Okay. So ModuleFast, this bootstrap script basically goes, finds the module and installs it. ModuleFast itself is all just in one file. And so if I Control KZ this, make this a little bigger. If I scroll through here, it doesn't have the line numbers, but you can see there's about 1,000 lines in this script. And that's because it is a self-contained, has everything in there that is required. There's no dependencies in the script. So it doesn't have to go out and get it and everything. In this script is everything needed to do the entire process of ModuleFast. So if you've ever built a module and you've done separate smaller functions and then you compile them into one big PowerShell module, it's like that. It's just for the nature of this, it didn't make sense to design it that way. It is broken into a lot of different functions that handle all these aspects. So up front are the key functionality that's like your user interface. And so you have the interface, and this has all the documentation, how to use the thing. I don't have a whole ton of information in here about how operations work, but these are sort of the key things. And then also the Git ModuleFast plan, how that aspect works. Then in the middle here, you have, this is a command that you won't use normally, but one of the things that I do here to make things really, really fast is built into every version of PowerShell is a special, basically it's an HTTP client. If you use invoke REST method, and if you ever read the source code of how invoke REST method works, way, way, way under the hood is this .NET library called HTTP client. It's a very powerful, pretty much every, ASP.NET uses this thing. Anything that pretty much is a modern thing uses this. It's very powerful, very effective. And so as a result, even with invoke REST method, there are certain things that slow things down for me. So I wanted to get to the very, very lowest level that I could so I could optimize the performance for the scenario as best that I could. And so this particular step that creates that handler does some of that setup. I want to be able to initiate 100 connections all at once to a server and be able to, if I get to that point, once I know about AZ, and I know that there's 80 dependencies, I don't want to get the information one at a time. I want to make 80 requests at once and have one thing that you find out about the PowerShell gallery is if you make those 80 requests, they all come back in about 500 milliseconds. It's about the round trip time, but it will scale. So fanning out to 80 doesn't cause the thing to bog down and die. Actually, they all kind of come back at the same time. But if I request them all at once, now my time is just 500 milliseconds, not 500 milliseconds times 80. And that same process applies to the installation process. I'm not going to go too much into the code of it till after we get through some demos, but I just wanted to show you is that there's a lot of detail here that handles how that processing works. So I'm going to go back to a different VS Code window here. So you'll see at the top it says SSH. That's because this is a virtual machine running in Azure. And the reason for this is to just show the best case scenario where this is a virtual machine running in Azure. It's over here in Germany, West Central. And it's sitting there like as close to where one of the PowerShell gallery instances is. So that to just show that what the max performance can be that's not affected by latency or anything. Because like if I'm over the Wi-Fi and the Wi-Fi is slow and downloading and installing the packages is slow, I can't get blood from a stone. I can't make that part go faster. So this example is to show like the best case if you're in a place in Azure where you have a great connection, which is typically like where a GitHub action and such would run, you can have this kind of performance. So if I go to my module, I'm just going to clear it out here. So right now, if I get my modules, I have a few modules here, but I don't have any AZ modules, as you can see. So in my demo, if I bring this back down, we have instantiated the ModuleFast, and I have left turned on verbose so you can see a little bit about what's going on. It just fetches the stream installs, but also I loaded it just now, so that's fine. Let me take the verbose back off. Because one thing is that this goes so fast that the output of the verbose will slow it down. Yeah. So the first thing, so this is an alternate way. I do also publish it to the PowerShell gallery if you want to have it available as a module. But again, the main thing is this is the primary intended entry point because it's faster. Because until like PowerShell Git version 3 is fast enough to make this part fast, you're bottlenecked by that whole process that PowerShell version 2 already does. It's not that much slower, but again, I wrote this that like every second, not every nanosecond, but about every like 10 milliseconds counts. If I could shave 10 milliseconds off, I implemented that. So we do this, we get that implemented, and so now we can start using this. So if we want to install an individual module, I'm just going to do, for instance, I'll just do on my local computer just as an example, which I think I may have. This is fresh, so I should be able to do install module, import Excel, verbose. We'll see if I don't have it or not. I don't believe I do on this one. So it's got to go. It's got to initialize all this stuff. Got to load that huge NuGet DLL stuff. And now it's going to search the repository, finds it, takes a half second there, downloads it. Now it grabs it, downloads it, installs it, does a check, and now we're installed. So, if I were to run a measure command on that, that was probably like 2 to 3 seconds to install import Excel. So I do install ModuleFast, import Excel. Of course, because we're PowerShell, I implemented what if. So if you do what if, you get a real nice view of, this is a sort of a special what if message where you get a nice little plan view that shows, here's your plan, this is what you're implementing, this is the version that's going to be installed. So you basically, if you've seen Terraform plan, this looks like that. Like this is what's going to get installed. So I do install ModuleFast, import Excel. It's installed. It did that whole process just there. Went out. What this looked like, in fact, I'll do, let me go ahead and show where it installs. So this is my local home folder. On Linux, it installs PowerShell modules. There's my import Excel. So I'll go ahead and delete it. This time I'll run it with verbose debug. And it also supports confirm. So you can do confirm, and it'll say specifically how many modules you're installing and be able to have that available. But here's the steps that basically went through. First thing it did was make sure that your module folder is in your PS module path. This doesn't matter on Linux, but on Windows, I decided that I didn't want to use the documents modules for this kind of stuff because any of you have ever had OneDrive sync your documents, all your modules get synced to OneDrive, causes a whole mess. There is a discussion issue in PowerShell to change it on Windows to go to local app data. And hopefully that'll happen for like PowerShell 7.4, 7.5, etc. But for now, that still happens. So the way that my ModuleFast works is that it will put it in the place where PowerShell will hopefully eventually put it on Windows and add it to your PS module path automatically so that you don't have to think about it. You do install ModuleFast and now those modules are available, but it's not going into your documents folder. It's going into this special local app data folder, which is more or less the same path on Windows. It's rather than local share modules, it's app data local PowerShell modules, but more or less the same path. So it does that, goes out, it checks if the thing is currently installed, which this is the most important step, is that if it's already installed and it satisfies what your version range is for it, then it's not going to try to install it. Just like Terraform. Like it's not going to try to build a virtual machine if the virtual machine already exists. Like why waste that time? And so it goes there, finds it, it sees the import Excel doesn't exist, and again, you get a lot of extra debug information you're not going to get. But basically the process works like this. Once it has the information about the module, then it kicks off this sort of complicated HTTP process using that HTTP client where it will go grab the module from the Azure CDN, which is always very fast. It's only the gallery, like searching of the gallery, that's slow. All the actual modules where they're hosted are hosted in a thing called Azure CDN, which is like a Cloudflare kind of a thing. So when you actually go to fetch the module part itself, that part's fast. That part's lightning fast. It's like reading it from a, like a storage account. And that happens with the Azure CDN distributed around the world. It's just the gallery part that's slow, that holds the metadata part. So I don't implement like anything special for that. I fetch that, but the difference that I do is as I fetch that, it gets read into memory, and then it uses this thing called streams in .NET, where basically it gets read into memory. Because it's a PowerShell file, it's just a new package is just a zip file. So before it ever touches the disk, it gets read into memory. As it's being streamed, it doesn't wait till it's done downloading. If it's like a 100 meg module, the second that data starts coming in, it starts getting translated and unzipped. And then once it's unzipped, it starts, as those bytes come out of that unzipped, it streams it right to the disk. So rather than save it in a temporary place, extract it to another temporary place, and then move it to another place, all of that is touching the disk, which is really, really slow. We keep all of that in memory and have that whole process happen in memory. So that's one reason why that happens really fast for one package. But like one package is not that big of a deal. But one other thing here is that if we do this again, you'll notice that that came back immediately. And the reasoning being, if we do verbose, it'll let you know, it immediately looked, hey, you have a module that meets this requirement. Your requirement was just any version, like, because you didn't like I said, import Excel, any version, it's installed, no need to go any faster. So, if you already meet all the requirements, I do a measure command here. Yeah, I don't know why that's not working. So, 125 milliseconds it took to execute that command. So, let's go ahead and try a little more complicated example.
Will this module path will be permanently expanded, or will it just be expanded when you import your ModuleFast?
No, so once you do an install, it's installed. So if you look in my PowerShell modules folder, there's import Excel right there. And it's there for as long as you until you delete it or whatever. This is just like any other modules folder. Does that answer your question?
No.
Oh, are you asking like how long does ModuleFast live?
No, how long does so you said you expanded the module path with on Windows with the local app data stuff. Is this a permanent action, or is it only?
Okay, good question. So the question is, there's a thing where I edit the PS module path so that it uses it. The script will actually prompt you. So if you're doing it and it does the PS module path, by default, it will just add it, and it will also add it a line to your profile. And that profile is a certain signature so that it knows it's the line and it will persist it. So it will automatically update your profile. If you don't want it to do that, it has a command line switch that's -no PS profile update. And you can also just do no PS module path update, because you can also install to custom destinations. If you just want to put it in like a temp folder to extract it, you can do that. So yeah, so by default, it permanently updates it, but there are command lines. If I pull up the command line switches of the module itself, you'll see up here, and you can also do git help. It's got all that info there. But if we go to the install ModuleFast, you'll see there's command line switches, no PS module path update, no profile update, and it explains, by default we do this, but specify this if you don't want to do it. Does that make sense?
Yeah.
So by default, like what's really nice about this is, again, if you have a GitHub Actions account and you use caching and such like that, this step is instantaneous because there's no updates that need to be done. If we go back to the ModuleFast here. So let's do something that actually has some dependencies, because that's where we've seen, again, the slowness, like with AZ. So if I do something like secret management key pass, that's dependent on the secret management module. So if I run that, now you saw how fast that was? So in that time frame, it went out, it fetched it, it found the information, and saw what it's dependent on. It's dependent on secret management, it's dependent on PS framework. It has all those dependencies. So now we can go ahead and install it without the what if. And you'll see, even though the progress, it would show you installing modules, it just installed that module. So just then, I just installed, you see, now I have 3 more modules here. So, okay, that's still better, pretty good. So let's try, one thing about this too is this is just text here because it's just the way that what if works. But if you want an actual declarative plan, you can use the git ModuleFast plan command. And now you have this object that clearly didn't work for some reason. Let's see here. I don't know why you don't want to work. Oh, it's because it's already installed. There's no plan because it's already installed. So if I, and that, again, everything has verbose. So if something happens weird, if you run verbose or debug, I try to be really careful with the messages to tell you this is why nothing happened, because I already have something installed that satisfies my criteria. So if I just take these guys and delete them so that they're not installed anymore, again, this is declarative. So you run the exact same command again, and now it analyzes and sees, oh, you don't have these installed. And so based on how you define these, you have ways to specify ranges, like maybe I don't want Pester, I'm still on Pester 4, I don't want Pester 5. You can define when you do the installation to say that, and it will match all that criteria, and it has a whole dependency handling logic. So if there's another application that strictly requires Pester 5, then it will either give you a choice to not install or allow those to install side by side, and you handle when those things load. But it will handle, like, if this application doesn't care what version of Pester is and this application requires Pester 4, it will automatically in the dependency tree figure out, okay, this is the common Pester that they're okay with. And that works with one module or 100 modules. So let's take this a little bit further. And then once you have a plan, as I have here, if you want to install that plan, the plan object, and you can go in that object, which, again, here's the textual representation. If you take it to a, well, that doesn't work, but I got it. If you look at the string versions of them, you get these nice little string representations of what they are. And you can also take, but they are objects. If I do the plan, take the first object, and I look at required, that's not just text. It's got a whole thing of versioning. It supports pre-releases. So you can tune and tweak this how you want if you need to, if you want to have a very specific plan. But this is something like you could put in a pull request and say, like, here's what's going to get installed before you approve. And so $plan, you know, and then you can pipe that into, I don't know if the pipe works because I was screwing with it earlier, but let's do install ModuleFast $plan dash what if. And see, now it'll use the plan to install, but the same result as if you would have typed it in. So let's do a stress test. These are 3 modules, Microsoft Graph, ton of dependencies. AZ, ton of dependencies. VMware PowerCLI, ton of dependencies. Let's see how well it handles these. So you see it resolving up. So the way it works is it starts with those initial dependencies, and then it's able to see the other dependencies, and it works in layers. It starts with that, and then it finds the other dependencies. But this is all written in an async way, so it's never waiting. It dispatches the requests, waits for, and then it just sits basically a loop where as the tasks come back, it does it. And this is all written in PowerShell. I didn't use C#. I used .NET concepts, but all that async stuff of tasks and stuff, you can actually kind of do that in PowerShell in a non-blocking way. So I didn't really see how long that was, but that was like, what, 3 to 5 seconds? And now we have, so we haven't installed the modules yet, but we have a plan. We have our whole dependency tree. To do that in install module, I mean, I could run it, but it's going to take like 5-10 minutes. Yeah.
How will make this discovery of the module dependencies?
Huh?
Module dependencies, libraries, and so on. How will make this technically discoverable? To understand which module depends.
So I don't expose like what's dependent on what in this, because it's just a plan of what's going to be installed. To discover what's there, you can use like find module on the individual thing. So if you do like find module, VMware, let's just do find module AZ, for instance. Let me just put this to a variable. So this, you should probably seen this output before. If you go a little bit deeper, there's one of these properties. It just lists what the dependencies are. And then you have to go to each dependency and get those dependencies. I don't build like a dependency graph. Yeah, just because it's not really necessary. But that's something that could be done as like a feature improvement. And again, if I didn't repeat it, the question is how do you see like where the dependencies came from? Like what relied on what? The other aspect will be is that if you run this in verbose and debug, we'll just do that real quick. I'm going to make this tiny because it's going to go by real fast. It'll probably also slow down the script because it's got a scroll apply screen, and that part's a little bit slow just from running it remotely. But if I do verbose and debug on this, you'll see all the details. It'll explain why it's not doing it. You'll see each of these, a lot of these things have common dependencies, like all the AZ modules depend on AZ accounts. So you see a lot of times where it says, hey, we already know about this dependency. We're not going to try to process it. Again, more performance saving, caching, etc. But it usually gives you a pretty good idea of why certain dependencies were chosen at that step. But I don't provide you with like here's where that came from. But you can analyze it pretty quick. So, that looked like it was scrolling pretty slow, but that's just because I'm running this in remote and all that's got to scroll over SSH. If you do this locally, it goes crazy, so. So, okay, well, we have a plan of what we can do. And if we want to see that plan, again, we can do the what if. And the second time I run it, notice it goes even faster. I'll talk about why that is. But you see that in about 2 seconds, it resolved 300 dependencies. So now let's take the what if off. So when I run that, here's where it's resolving the dependencies. This step always happens first. We always plan before we apply. That's one part to performance that I don't do. Do you see that? Do you see that over there? See that all those modules just suddenly showed up? In that time frame just there, it fetched 200 modules, and using that framework, those 200 modules are now all streaming at the same time, coming in, and then it's throttled to 200, but you can also set the throttle to like 50 or 20 if you need to. But they all came from the Azure CDN, fed into the computer, and all in separate tasks were chained together where package comes in, gets unzipped, and then gets written to the disk all through memory. It never touches the disk until it's actually being written into this folder. So that saves a ton of time, because the time you take going to disk and back is thousands and thousands of times slower than just doing everything in memory. Now, if I were to run a graph on this, especially if you do this, you'll see the memory like spike like crazy. Like, it's going to hold like 2 or 3 gigs of memory, but then it releases it. If you don't have that much memory on your system, that's fine. It'll throttle for that. But you just, unused memory is wasted memory. It just does that. And in a lot of these environments, there's plenty of memory to do this kind of thing. This isn't going to work on like a Raspberry Pi. It will work, but it will be much, much slower than like what I showed here. But that's like another example of like where I was able to get performance improvements. But here's all the AZ modules. And again, because it automatically, in my PS module path, on Linux, it's already there. But if I do git module AZ star, I got your list available because I don't have them loaded. There's all the AZ modules installed. And you saw that if you run that command normally, that takes 15, 20 minutes with PowerShell Git version 2. Not much better with PowerShell Git version 3 due to how it's currently implemented, and that took like 15 seconds. I made a tweet about this once, and it was pretty fun. So I forgot to mention too, it's not just AZ. Here's all the Microsoft Graph modules. Here's all the VMware SDK modules. It wasn't just AZ. It's all of that. In fact, let's see how much space does our modules folder take up. Copy path, df this, du-sh this. So that was 2.2 gigs of modules downloaded that fast. Now I am wired here. I'm on gigabit. Actually, this is in the Azure data center, so it's in a virtual machine that has like a 10 gig connection, and it's right next to where the Azure CDN is. So this is like best case. But even then, like here I am on just this isn't even working, so I'm still just on Wi-Fi. We'll see how well it does. First, ido aka bit.ly/ModuleFast, real simple, get it fetched. There are ways to actually run it without even having to do the second step. You can run it directly from that, but I'm not going to cover that right now. And install ModuleFast AZ. Oh, I already have installed, so it's probably going to be real fast there. Yeah, all required modules installed for AZ. Let's do -update, which will at least do a dependency search. So a little bit slower, but you see it's still pretty fast. And so the reason that that's fast, just to wrap this up here real quick, is the PowerShell gallery is slow. So I made a proxy for it. I made a thing that basically, one of the things that was really slowing me down was going to the PowerShell gallery, that 500 milliseconds. So I made this thing called pwsh.gallery, which if you browse to it, you'll just get it like a 404 error because it's purely built for API. What it is it's a NuGet version 3 to NuGet version 2 bridge. And it's written in TypeScript, and it's using a thing called Cloudflare workers, which are basically just Azure functions on steroids. Because you can't write, you have to write them in TypeScript, but because they can just run in the V8 runtime, they don't need a virtual machine. You build like a 1 meg package, and it gets deployed to 180 data centers immediately. Everybody gets it, and it uses all the caching and operations for that. So here's I got timed out here, but here's where the Cloudflare worker lives. You won't need to know anything about this, but basically what happens is that I basically have a caching proxy in front of the gallery that when you make a request to the gallery, it goes back, makes the version 2 query to the gallery, converts it to version 3 because version 3 is much more documented, version 2 is undocumented, and then returns that to the client. But then it remembers what that result was. So the next time the client comes, it bounces right back off that from cache. So the first time you run it, it's all coming from the origin, can take a little while. And that's from a region. So like we're here in Germany, I'm getting like one of those 180 nodes that's specific to Germany. On the back end, they also share a global database so that they all have a secondary cache for that. In short, it's really, really fast. That it will, like this is, in my opinion, how the PowerShell gallery should work. And hopefully how when they move to the containers thing, it'll be a little bit closer to like what that's going to look like. But basically, it makes things really, really fast. That's why the second time I ran that AZ was so fast, is because my gallery, my module already knows about. It doesn't even have to touch the PowerShell gallery. The PowerShell gallery didn't even see that. My workers just got that and came back. And by the way, workers, you get like it's just like Azure Functions. You get like 1 million executions for free. This doesn't cost me anything to run it. Like it's had like it gets like 32,000 requests a month, and it doesn't cost me anything. So like here, there's 3,000 requests just today. There's all those requests coming in. And that's that huge fan out of AZ requests and then getting that information. And also because I don't proxy, because we still just fetch the full modules from the Azure CDN, I don't have to proxy that part. I just redirect to that part. So that stuff doesn't have to flow through my thing and incur a lot more cost than it would otherwise be. I basically just made a faster gallery while keeping it compatible with the existing one. So, because we got a late start, I just got one more thing that I'm going to show in my list here. I just want to show how much more complicated it is. So for instance, if we need a max version of Import Excel, you can use the same module specification syntax that you're probably already familiar with if you've done install module. It supports all those parameters too, but you can even make a requirements file. So in here, I have a PSD1 that says, this is my program. I need these particular things. And again, that declarative thing, this is what I need. If there's conflicts, just figure it out and install this for me so that when I'm running my Azure function, I want all this stuff just ready to go as I start. So you can take this, copy it, do my console here, pipe it into Get ModuleFast plan, do the same planning, and now you've got your declarative what this is going to be. You can also just pipe it into install. Yeah, so like this is my baseline modules that I want my Azure function. If you've used Azure Functions, you know they have that required module thing, but that still uses PS Git version 2 in the background. So your cold start, especially if you want to install the whole AZ module, like your cold start on the thing is like 2 to 3 minutes. Whereas if you have this, the first cold start, because you're hitting that Cloudflare, might be, 3 to 5 seconds. And then after that, subsequent cold starts, because now it's cached in the Cloudflare, are as fast as it can hit that Cloudflare node. So which is, milliseconds sometimes. So that's how that works. It provides all that kind of functionality. Again, it's mostly optimized for this case. There's tons of bugs still, but this is just an example of how fast module installation can be. And here's an example of importing that data file, getting the plan, and then teeing it for those requirements. And it looks like it got stuck on resolving something. I don't know why that's taking so long, but... And then taking that plan, and this would be, I did the what if so I can see what was going to be installed, but if I actually run it, then it will install those things. And this time, because I have some extra included things, you'll notice some things got installed, some things it recognized were already installed, so it just skipped them. But you saw in just those couple of seconds, now I have here in my local PowerShell modules, in addition to all this stuff, I have those additional new ones like Pester and PowerShell AI, etc. So really fast way to keep, maintain, and update modules. If you're really interested in how this works, I could do a whole session just on how the code works, which is I think I invented a lot of kind of interesting techniques that can be, if you're doing really advanced PowerShell stuff, you'll see stuff in here like the core of like how the processing works. You'll see a lot of like .NET typey stuff in here. Let's see, actually, I'm going to find memory stream. That's a task. So the way the core part of this works is there's all this task stuff. So it uses .NET tasks to stay really, really fast, which are even faster than PowerShell run spaces. And it basically just has a loop that dispatches the tasks, and it sits on that loop, waits for the tasks to come back, and as soon as the tasks come back, it processes it. So that processing part is mostly just saying, did this work or did it not? So if there was an error, it'll handle it. But otherwise, it just knows that it worked. All the actual work is done in that task. And so it's able to fan it out to multiple cores, all that kind of stuff. But this is a way to like do things in parallel in PowerShell. In my case, even run spaces weren't fast enough. Like run spaces like had enough overhead that it slowed things down, required a lot of memory because it's got to load all this extra PowerShell junk. All of this stuff is pure, super low level HTTP client tasks, but you can handle them in PowerShell where you can just dispatch everything out and then as stuff come in, handle it. So it does bottleneck at that one, like that loop, but that loops fast enough because all it's doing is just verifying that nothing went wrong, that the whole thing actually can be pretty much almost as fast as it would be in C#. Question, yeah.
Yeah, maybe a bit technical about the HTTP client. We have only one copy of this.
Yeah, good question. So the question was, for my HTTP client, do I only have one copy? And so as a result, what happens is in this one, it does only have one HTTP client that's used for everything. In fact, that get HTTP client command that I showed is how you can build your own if you want it, if you need to inject like authentication because you're using a private thing. This also works with any new Git version 3 repository. So if you want to target it to GitHub packages or the new Azure DevOps feed, it works fine. But if there's like a new authentication or you want to tweak and tune the client, you can do that. But my program reuses that HTTP client. It used to, if you work in C#, you know that there's an issue like if you build a bunch of HTTP clients, you can run into what's called a socket exhaustion issue. That actually hasn't been true since .NET Core 2.1. It's actually one of those urban legend things that if you're on PowerShell 6 or newer, it's not a thing. And that was fixed so that they use a common HTTP handler. You can make as many as you want because they make that all still use a certain shared thing. So I'm about out of time. I'm out of time. So if you want to discuss some other things, I'll be out in the lobby here. Maybe if the podium is available, we can do a little follow along. But again, thank you very much. Hope that was interesting and have a great day.